So today we discuss about the two methods, two iterative methods which are used to solve the system of linear equations. So the first one is the Jacobi iteration method. The Jacobi iteration method is an iterative numerical technique used to solve a system of linear equations. It's particularly useful for large sparse system. The method starts with an initial guess for the solution and iteratively refines it. So what is the meaning of sparse system is there is a, now suppose that we discuss about it when we take one example. So let me go ahead. The method start with an initial guess for the solution and iteratively refine it. The Jacobi iteration method is effective for diagonally dominant or symmetric positive definite matrices. So let us see, let me take one example, and with the example, I will tell you different steps, right? So the example number one is apply Jacobi iteration method to solve the system of linear equations 20x plus y minus 2z equal to 17, 3x plus 20y minus z equal to minus 18, 2x minus 3y plus 20z equal to 25. So we have given three equations. So obviously we know that this system of linear equation can be also solved using another method like that. We can also solve by using elimination method, Gauss elimination method, metric inversion method, Kramer rule, or metric rank method. So we have different method. We using that we are able to solve this system of linear equation. But now since here there are only three variables, so this what are the methods which we have studied till now? They are very simple if we have given the less number of variables. But if we have given the more numbers, now here we have given only three variables. If we have given 10 variables, 20 variables, so at that time, that method will not be the very simple. That will be more complicated. Because if we have given the 20 equation and 20 variable, then it will take very much time. And it may also happen that we won't get the exact solution. Right? So now the Jacobi method, iterative method is what? It is, so now we are taking the simple equation, 3 by 3 equations, but it can be increased up to 1000 equation also, right? So let me just see the procedure, what are the procedure over there, and then we will try to solve the system in which more than 3 equation, 4, 5, 6, and so on. So the first thing, how to solve this question, here the given system of linear equations is diagonally dominant. So it can be written as, what is the meaning of diagonally dominant? So just look here. Here, if we see in the first equation, now this is A11, A22, A33. How we are able to write down the system of linear equation? We can write down like this. A11x1 plus A12x2 plus A13x3 plus A1n xn equal to B1. Similarly, A21 x1 plus A22 x2 plus A23 x3 up to A2n xn equal to B2. So similarly, we can write down that n equations. So now what is that? A n1 x1 plus A n2 x2 up A n3 x3 plus A nn xn equal to bn. So now we have first equation, second equation up to n equation. So this what we are getting A11, A12, A13, A11. This is what? It is the coefficient matrix. Similarly, A21, A22, A23, A2n. So we will get the n by n matrices. So now here, what is the meaning of diagonally dominant? So first look here that A11, A22, A33, A44, A55, AN. This is what it is called diagonal element of the given matrix. So diagonally dominant means what? Just look here, A11 is 20, A22 is 20, A33 is 20. And the remaining two terms, just look in the first equation, it is 1 minus 2, which is very less as comparing to the 20. Here 3 and 1, which is also very less as comparing to 20. Here 2 and 3, which are also very less as comparing to 20. So this is called diagonally dominant. If one coefficient of one variable in each and every equation, one equation will be larger than the sum of other two variables. So how to write this equation? So we will just write down from the first equation. Just see the first equation. We have to write down, we have to transpose y and z in the right hand side. So 17 minus plus y will become minus y, minus 2z will become plus z. And what is the value of x? It is 1 by 20 times of 17 minus y plus 2z. So this is the first equation. Similarly, we are also able to write down in the second equation here. What is the coefficient of y? It is 20 and it is larger than as comparing to the other two coefficients. So we write down y, which can be written as minus 18, minus 3x and plus z. Minus 18 minus 3x plus z. Similarly, the third equation can be written as for z. So what is the value of z? It is 25 minus 2x plus 3y whole divided by 20. So I think this is clear to all of you how we are writing x, y, z.
Yes, sir.
Yeah.
Yes, sir.
Okay. Now, if we want to do the iterative iteration method, so we have to always take the initial condition, our initial values of x, y, z. So the first iteration, we start iteration with initial approximation. Let us consider x0. It means that it is the initial approximation, y0, z0, and all three variable has zero value. So if we put it in the equation number 1, so what we are getting, x1 means first iterative value of the given value x, variable x. So now here 17, the value of y is 0, value of z is 0. So now this is what it is, 17 upon 20. If we simplify it, we are getting 0.85. In the same manner, if we put the value of x and z 0 in the second equation, what we are getting minus 18 upon 20, which is minus 0.9. And if we put x and y 0 in the third equation, we are getting z1 is equal to 25 upon 20, which is 1.25. So this is the first iteration where we are getting the value of x, y, z when uh, putting the values of initial values of x, y, z equal to 0. So this is the iteration number 1. Now we continue this in the second iteration. So what is the second iteration? So for the second iteration, the value of x1 will be 0.85. The value of y1 is equal to 0 minus 0.9. And the value of z1 is equal to 1.25. And the equation will be same. In this equation, now we put the value of x is 0.85. The value of y is minus 0.9. The value of z is 1.25. Let me go to the second iteration. So same thing we are doing over there. Now, this if we want to solve this equation, this questions, we have to use the calculator, scientific calculator, right? So that's why the calculator are always allowed during the examination when we are studying about the numerical techniques. So please use the calculator. And now, if we put the value of x is 0. Y is minus 0.9, value of z is 1.25, because the first is what? It is the term of y and z. So we are getting the value 1.02. Similarly, for y2, it is minus 0.965. Similarly, for z2 means second value of x, y, z in second iteration. It shows this 2, 2, 2. What it shows? It shows the which iteration we are doing. So here we are going to do, we are doing the second iteration. So that's why it is written as x to the power 2, y to the power 2, and z to the power 2. It denotes the iteration. So again, if we are putting all those values in the given equation, x equal to this, y equal to this, and z equal to this, then we are getting another three different values of x, y, and z. Now, if we, so this is what it is, second iteration. Again, we repeat this process for in iteration number 3. And what we will do over here, our initial value will be for x, it is 0.1.02. For y, it is minus 0.965. And for z, it is 1.1515. Again, we substitute all these values in the same equation number 1. We have another values of x, y, and z in the third iteration. So which is what? The first value of x is 1.0134. The second value of y, third value of y, which is minus 0.9954. The value of z is 1.0032. So this is third iteration. Now let us go to the fourth iteration. In the fourth iteration, we have again the first, what are the values which we have obtained in the third iteration will be the initial value, and that will be substituted to the again equation number 1. We have these values x, y, and z in the fourth iteration. If we go to the fifth iteration, for the fifth iteration, these values are the initial value for x, y, and z. So if we want to write down the value of x, y, z in the fifth iteration, we are getting x equal to 1.0000, y equal to minus 1.0002, and z is equal to 0.9996. Let us go to the sixth iteration. What will happen? So if we go to the sixth iteration, we are getting 1.000 minus 1.000, 1.000. And after that, if we go to the another next iteration, we get the same answer. Why? Because there is no change in the values. So sixth iteration and seventh iteration, we are getting the same answer. So now when we are getting the values of x, y, and z same at the next consecutive iterations. So we stop over there, and this is our solution of the given system of linear equations. So what is our solution? Since the values of sixth and seventh iterations are same, so the solution is given by x equal to 1, y equal to minus 1, and z is equal to 1. So this is the complete procedure of Jacobi iteration method to solve the system of linear equations. So here we have taken 3 by 3 variables. So sometime we can also take 4 by 4 variables or 5 or more variables to solve the system of linear equation using the Jacobi iteration method.